Professor Mitesh is from the Department of Computer Science and Engineering of IIT Madras. He is an expert in machine translation, text analytics, and deep learning. Welcome, Professor.
Hi everyone, good morning. So I would like to talk about our work on machine translation to make MD systems for Indian languages accessible at high accuracy for all the 22 scheduled languages. Okay? So before I get into the details of the technical details and so on, I would like to just give you an overview of what we are doing, why we are doing it. Right? So I head the AI for Bharat Research Group at IIT Madras, where our mission is to ensure that for all the 22 scheduled Indian languages, we have parity in AI technology with English. Right? So what does that mean? Simply stated, it means that today for English, you take a lot of things for granted, that if you want to do sentiment analysis, here's a model, it will work out of the box very well across multiple domains, right? If you want speech recognition, you have models like Whisper, open source models from OpenAI, other open source models, commercial models, which work at fairly high accuracy across a wide variety of domains, across a wide variety of demographics, right? So even Whisper, for example, right, even does a fairly good job of recognizing Indian accented English speech. Now, why we take all of this granted for English? I come back to my statement of bringing parity in AI technology with English for Indian languages. So what I mean by that is that we're going to go to a state within the next 1 year, 2 year, time frame where we get to a state where all these technologies we take captive for Indian languages also, right? And which are the technologies of interest? Everything which comes under language technology broadly, which is machine translation, speech recognition, speech synthesis, and optical character recognition, and now of course large language models, right? And I believe Professor Umesh and Professor Hema would have already spoken about speech recognition and speech synthesis for Indian languages. I'll now talk about machine translation, right? And here, right, so what I want to give a perspective on is that if you want to build these technologies for Indian languages, right, so what are the missing pieces, right? Why is it that machine translation systems for Indian languages, say 2 years back, 3 years back, at least in the open source, did not work as well as commercial systems, right? So the main difference is in data, right? So we really don't have large amounts of data to train our models, right? So any commercial systems that you take, they are trained on order millions of sentence pairs, right? So how do you train a machine translation system? You have a lot of English text and parallel Hindi, Marathi, Gujarati text, right? So this is how I say I want to eat food now in English, and here's its translation in Hindi. And imagine millions of such sentence pairs coming from a wide variety of domains. And you feed this to the machine model, and then it learns certain correlations and patterns. Like, okay, whenever I see want to eat here, I see khana chahta hu here, right? So maybe these two are translations of each other, and maybe I'll stitch new translations by learning from these patterns, right? So that's how the model learns, right? So unless you have very large amounts of data in these languages, you'll not be able to build machine translation systems for these languages. So what we are focused on in this work is to mine a lot of data from the web, right? And I'll try not to go too deep into the technical contributions. You can look at the paper for that, but try to keep it a bit at a high level. How do we mine such data? Right? So we are a very fortunate multilingual country, right? In our country, newspaper articles get published in multiple languages, right? So if there is an important event, say a G20 summit happening, and say but Prime Minister Modi, suppose, met someone very important during that meeting, then it's likely that newspaper article covering this event will get published in multiple languages, right? And then it's likely that these articles will contain some sentences which are parallel across these languages, right? So simple example would be that, hey, the police nabbed the culprits who are trying to escape. This is an important news. It would be published in multiple newspapers, and this exact sentence in some form would be present in English, it would be present in Hindi, it would be present in Marathi, and so on. So can I automatically get this data from the web by finding parallel sentences for a given English sentence or Hindi sentence in multiple languages, right? And turns out that we can. And what we show in this work is that you can mine a large amount of corpus for Indian languages from the web. And we mine around 232 million sentences from the web. This is of course noisy data. Not all of it would be perfect translations. But the current deep learning systems are quite robust to noise, right? They are able to deal with this. And they're still able to learn some basic patterns from this data, right? And that shows up in the results where our models I show now are better or comparable even to commercial systems available from Google, Azure, and other deep tech industry, right? And the other problem that we see in Indian languages is that people don't really create good benchmarks for evaluating translation systems in the Indian context, right? Now, where would I use a translation system? And I'll show you an app soon, which is built as a part of the Bhashini project. We use translation systems for everyday usage, right? So if I am I do not speak Tamil and I live in Chennai, and I want to go to a grocery shop, I would want to do a transaction where I say that I want 5 kg potato, 2 packets of bread, 1 packet of butter, and I want the grocery shop owner to understand this. In many cases, I do get by with English and Hindi, but suppose it's a situation where the person only understands Tamil and I only speak English and Hindi. I want to do a translation. I want to have a service which can do a translation of what I am seeing, right? So now what does that mean? I expect in the Indian context, I want translation systems to work for Indian use cases. Right? And what are Indian use cases? We interact with food delivery services, we interact with grocery shop owners, we interact with, of course, a lot of this is urban, my urban viewpoint, and there are equivalent rural use cases. You may have ride-hailing services and so on, right? So can we create benchmarks which evaluate the existing machine translation systems on these India originating use cases? Okay? So that's the second contribution that we have in this work, where we want to evaluate a bunch of systems on Indian use cases. And the last is, of course, when we put out models, it's important that for the ecosystem to grow, that we put out these models as well as data sets with highly permissible licenses, so that any startup, Indian startup working on machine translation or wanting to use it as a part of their business can use these models without any additional cost or licensing cost. Of course, they have to deploy it themselves and bear the deployment cost, but that's fine, that's a part of their business. But at least benchmarks. We are now either comparable or better to them. Of course, this is an average number. You have to zoom into the number of benchmarks. You have to zoom into the number of languages are averaged across all of those. And now we have systems for Indian languages which are comparable or better than commercial systems. Right? And this is what the journey has been for the past 2 years. Another way of looking at it is through this bubble chart. Right? So what you see here, will this work? Hello? Is it working? Okay. So what you see here, right? So in 2020, Facebook had released a machine translation model, right, which worked for 100 languages. But whatever you see below the red line, those are the Indian languages which were not a part of this model. Right? So there were 10 plus Indian languages out of the 22 that were not a part of this. And on the other languages, these are the accuracies that we had. And we had some work in 2021, the first version of our work, where again we could not handle all the 22 languages. But for the top 12 languages, we are able to push the quality above. Right? And here each bubble is proportional to the speaker base for that language. So you can see that Hindi is the largest bubble because it is the largest speaker base in India. Then Facebook released a model in 2022 again, which covered 40,000 language pairs. And again, some of the Indian languages were left behind, but they did push the accuracies for the other Indian languages, right? And this is what we did in 2023, where now no Indian language is left behind. And many languages are close to this green mark, right? So this green mark is something, if you reach an accuracy of around 60%, you can start deploying it in post-edit use cases, right? I'll tell you what a post-edit use case is. A post-edit use case is something that we're doing with the Supreme Court. So Supreme Court, since its inception, has some 35,000 judgments which have been released. And the new Honorable CJI has a mandate or has set up a mandate that all these judgments should be translated into 22 Indian languages. Now, if you were to do this manually, this is an extremely tedious task, right? And what I mean by crossing this level is that if I use a machine translation system as the first translator, and then ask a human to edit the output of the machine translation system, then the human would prefer to do it this way, as opposed to saying that, hey, your MD system is so bad, I'm anyways deleting most of the stuff that it is producing, so let me translate from scratch, right? So this is the level at which humans start preferring. This band that you see here is the band in which humans start preferring machine translation output as the first starting point instead of translating from scratch, right? So for most Indian languages, we are there, and our goal is by next year, we want to push all the Indian languages into this band so that post-editing becomes a viable option, right? Another way to look at this is that, hey, this is only 60% accurate, then why should I use a machine translation system? It's not an accuracy argument, it's an efficiency argument. So today, if a human translator takes 5 days to translate one judgment, with the help of the machine translation system, if you can bring that down to 2 days, right? So in 5 days, you can translate many more judgments than what you could have done earlier, right? So that's the argument, that's the way to look at this. And you want to make this as a viable option in multiple government services, right? Now, using the machine translation systems that we have developed, as well as speech recognition and speech synthesis systems that are developed by various partners within the Bhashini consortium, we have developed an app, again a part of Bhashini, which allows you to translate between multiple languages. So let me just open that. So let me see how this demo would work. So I'll speak something in Hindi, then I'll ask it to translate to Tamil. Okay, and then ask you guys to also use it. Okay. आज यहाँ आके आप सबसे बात करने में मुझे बहुत खुशी हुई. So as I speak, it first has to recognize what I have said in Hindi, then translate it to Tamil, and then speak it out in Tamil. Right? So let me now speak out the Tamil translation that it has done. Was it appropriate? Okay, cool.
Thank you, Professor Nitish, for all the contributions you have made in machine language translation. It's a small moment for you.
Thank you.